For another example, I'd like to find a power series representation of the following function. This is f of x is equal to x over 2x squared plus 1. Now the big thing that we need in these cases is we need to make sure that our 1 is the first term of the denominator. So I'm going to express this as x over 1 plus 2x squared. And in order for us to get the geometric series solution, we would need 1 minus something, which means that I'm going to change this plus into minus a negative. As a result, we'll get x over 1 minus negative 2x squared. Written in its particular form, we have the geometric series formula with a being this and r being this. So with that in mind, we can transfer back to a geometric series and call this the sum from n equals 0 to infinity of the first term times the common ratio raised to the n power. Now if you'd like to leave it there, you're welcome to do so. However, if you're interested in doing additional work with it, we can start by distributing the nth power to both of the factors inside the parentheses. Call this x times negative 2 raised to the n power times x raised to the 2n power. Multiply the exponents together when you have a power to a power. Then with x times x to the 2n power, we can combine those together to become x raised to the 2n plus 1 power. Now we should probably figure out the interval of convergence as well. Our common ratio was this. The interval of convergence will give us the domain of our power series representation. So we would need that negative 2x squared is in between negative 1 and positive 1. However, saying that it's greater than or equal to negative 1 is kind of, less than or equal to positive 1. Why don't we just go ahead and divide through by negative 2 first, and then I'll describe what's going on. So dividing through by negative 2 will give us x squared in the middle. Dividing negative 1 by negative 2 will give us positive 1/2 and reverse this sign, so that's now over here. And dividing 1 by negative 2 is going to give us negative 1/2 and reverse the sign, so that winds up over here. Now saying that something squared is greater than or equal to a negative value is superfluous and redundant, much like the statement superfluous and redundant. So we can just say that x squared is less than or equal to 1/2. Now if you'll recall though, if we were to consider y equals x squared and y equals 1/2, the corresponding x values extend to the right and left of 0, giving us another compound inequality. Or more specifically, when we take the square root of both sides, it's going to give us that the absolute value of x is less than or equal to 1 over the square root of 2, or more succinctly, x will be in between, I don't know that it's equal. It'll give us that x is in between negative 1 over the square root of 2 and positive 1 over the square root of 2. If you wanted to figure out whether or not it's equal, you could do so by testing the endpoints back in the original power series that we came up with. So for now, we'll say that this is our domain, and that's close enough.